engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
We got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading.
And of course, a very good time of the day to you joining us now from wherever you are from wherever you are on Earth, right? Well, last time I checked our numbers, or the listenership for the Void Show. Well, people who are listening to the Void Show are only from Earth. Well, that's what the statistics said. And I don't know if that's a good thing or a bad thing, but I guess it's a good thing. Hence, I digressed and I said that, well, on Earth, right? It's pretty fair. I mean, it's not like there's somebody sitting on a chair in a very warm place in the universe, stressing about life, listening to the Void Show, right? So that's me just saying welcome to the Void Show. We are on Active FM. As all of us keep saying, radio has never been better. My name is Andrew. I am your show host. I'm really excited to be here today. And I hope you are well. And also you are really looking forward to the show, right? You are like, well, what is it that I'm going to be learning today? By the end of this show, what is it that I would have learned today, right? Because I can assure you, we're going to have a great show today. We have some common misconceptions that we're going to discuss towards the end of the show. So you definitely want to hear those common misconceptions. We have about 2 of them, and we're going to do that every week from now. We're going to be having those common misconceptions while relating to the topic that we are discussing, right? Because there are always common misconceptions. Is it conspiracy theories? I don't know, whatever that means to you. So, yeah, and you surely have seen what we are discussing today, the cosmic messenger. And you say, what on Earth or what in the universe could be the cosmic messenger? You know, astronomy is not only one of the oldest sciences to ever exist. Okay, it's not only one of the oldest sciences to ever exist, but it's also an inherently interesting science, right? Because as we've mentioned before, this is not new. This is not new, right? Even a toddler knows this. Like things that we study in astronomy, it's things that are out of reach, right? It's not something that when I'm feeling bored today, I can just go to Pluto, right? On a vacation to Pluto. It's not something like that. Well, maybe in the future that could happen, right? Probably not in the near future, but maybe that would happen. But objects that we study are not within our reach, right? Of course, we can go to the moon. That's possible. But you see, there's a whole bunch of things that are involved in. I mean, last year, NASA sent a space rocket to the sun, right, to the surface of the sun. Well, that can happen. But there's a lot of things that go behind the scenes. I mean, it's costs, it's money, it's the hardware, it's the software, right? So it's really a complicated thing. And I mean, when we start to speak about stars, these are billions of light years away from us, right? So we don't really, or we're not able to touch them, right? So now the big question is then, how do we know what we know? Hey, well, I mean, if you hear an astronomer speaking, they would be telling you that stars are this is happening, the helium stars. I mean, these are like light years away. What are you saying? What are you saying? How do you know that a star is just a ball of gas? How do you know that? How do you know that it's hydrogen? It's a helium atoms. It's a helium gas that is there. How do you know the temperature of the star? How do you know whether the star is moving towards us or away from us. How do you know these things? So today we're going to be answering that question, and it's a pretty simple answer, right? We have a pretty simple answer for that question, and the answer that we have is that we know what we know because of what we call the cosmic messenger. So I'm going to leave you to that, and when we come back, we're going to say, what is the cosmic messenger? And you might just want to guess what is the cosmic messenger, and when we come back, we're going to tell you, and enjoy the rest of our show.
Hey, hey, it's a blues world. Hey, listen, Active FM in the building, yeah, you know what I'm saying. Radio never has been better, so keep listening and stay tuned to these tunes, cause they keep hitting the stage. Stage 1 to stage 12, our load is amazing. Sharing only facts, cause you know we are different. Yeah, we're different, far from average. Podcasting could present your favorite station, nah. Are you comfy while you study? I just hit the play. Become our family, our presenters keep you up to date. You'll never lose, cause it's blues and them giddy shows. Don't hit the snooze, cause our news, yeah, we ahead of the world.
Turn it on. Turn it up.
Alrighty, great. So, well, I gave you a task, and the task was you should come up with a hypothesis, right, an educated guess to tell us what is this cosmic messenger, right? So this cosmic messenger is the thing that has enabled us to know what we know about the universe. If it weren't for it, we wouldn't know nothing, right? There'd basically be nothing that we know. So what is this cosmic messenger? And the cosmic messenger is light, right? It's light. So we know what we know because of light. Well, we had a show where we spoke a bit about light, right? What actually is light. We spoke about the electromagnetic radiation. If you are interested in that stuff and you want to know more about it, you can check the show out, right? It was titled Light. We spoke about things like color, and it was a pretty cool show. It was a really, really informative show. But now what we are going to do is we want to understand, how do we know what we know about celestial bodies through light? Okay? Because the truth is, almost everything we know about the universe is we know it because of light, right? It's identified through light. You say, well, what does light have to do with this? What does light have to do with this? What do you mean, light? Well, the answer is simple. Because not only we know what we know about the universe because of light, but you also know what you know about everything because of light. Right? You are able to discern distinct things on Earth and in space because of light. If I say to you, look around you and tell me what you see, right? You're going to tell me, I see a fridge, I see a mug, I see a cupboard, I see a wall, right? That's fair. But think about this. Were you going to tell me, or would you be able to tell me what those objects are if there was no light? Would you be able to tell me? I don't think you would be able to tell me that, right? So what's the point that I'm trying to drive home here? The point that I'm trying to drive home is this. In honest truth, yes, you may be seeing a fridge, yes, you may be seeing your cell phone, but what you are actually seeing is light that has interacted with these objects. right? And through experience, through knowledge, through intuition, you are able to say, this is a fridge, this is a table, this is a pen, and this is a cupboard. Okay, do you get me? So in other words, you have light, okay? And this light, it interacts with these objects, and because of this light, you are able to have knowledge about a certain object because of this light, right? So this light has interacted with your fridge, and your fridge is obviously white in color. Well, it's because of that light, right, that you are able to tell me the properties of this body, which is a fridge, right? It's because of this light that you are able to tell me that this fridge is actually a solid, this fridge is white in color, it's got a pink lines along it. It's because of light. So because there's light, then you are able to tell me what the properties, or the characteristics of a certain body, right? So really, all that you are seeing, yes, it could be those things, but it's just really light that has been reflected from these certain bodies. And we're going to be speaking about how light interacts with matter, right? We're going to get that. We're going to get there now. But do you really get my point? If there was no light, then you were not going to be able to tell me anything about the fridge. You were not going to be able to tell me what is, the color of it. You were not going to be able to tell me how it looks like if there was no light. But because of the light, then you are able to tell me that the fridge is white and this is what's happening on the surface of the fridge, right? So it's the exact same process in astronomy, right? I mean, you didn't really have to go to the fridge to touch it to tell me the properties of it, right? So it's the exact same process that we use in astronomy, right? So what do? We collect the light from these bodies, in other words, from these stars, because the stars are not the same. This is so interesting, and we're going to be speaking about it. But you see, stars are not the same. They differ in temperature, right? And because they differ in temperature, sometimes you see stars. I mean, when you go outside in the night sky, you look at the night sky, some stars would appear bluish, right? Those are the hottest stars. Some stars would appear, reddish, orangish. Those are cooler stars. So, they differ in size. It's different stars. So how do we learn about these stars? How do we learn about what are they made up of? How do we learn the temperature? Well, firstly, the thing is how they made up of. We collect light from these stars, right? Pretty much as how telescopes work. They collect light from these stars. So we collect light from these stars, and when we analyze that light, we are able to discern and say, okay, because of the lifetime that we've lived on Earth, we know there's these elements on the periodic table, and we've studied these elements. And when we analyze that light from a certain star, we are able to say, okay, this is what this star is made up of. Okay, and that's physics. Because what's actually happening when you are looking at your fridge or your computer, you are really seeing light that has interacted with your computer, right? And obviously when this light gets in your eyes, your brain acts as some sort of an analyzer. So it analyzes what? It analyzes the light, right? It gets in your eyes, it goes to your retina, right? And obviously when it gets to these cells, your brain would analyze, it acts as an analyzer. It would analyze the light that you have received. And obviously through experience, through knowledge, through intuition, you are able to say, hey, this color is white, right? Because you know a white color, which is through experience. So it's pretty much the same thing, because we know elements that are on Earth or in the universe. We've analyzed them. We know them through experience, through intuition, through knowledge. When we analyze the light of a certain star and we put it there, we analyze it, right? This is physics. It's a bit much complicated more than this. but this is physics. So when we analyze that, then we are able to say, okay, this star is made up of this gas, right? Maybe helium or hydrogen, right? So that's pretty much it. And when we learn about light, and obviously this is sort of like an optical physics, when you learn about light, you would find that light is actually energy, right? It's energy. We know that light is energy, right? Because when you go outside in a sunny day, you can feel the warmth in your skin, right? Why? That's because light is a form of energy, right? We've got different kinds of energy. We can speak about the kinetic energy, the potential energy, and then light is a form of energy that we call radiative energy, right? Is a form of energy that we call what? Radiative energy, right? Because it radiates, right, from a central point. It radiates. Obviously, when you turn on your bulb, it radiates. Light radiates from the bulb. From the sun, light radiates, right? So it obviously carries energy, but we don't normally measure. Like in astronomy, we're not really interested in the total amount of energy that the light carries, right? That would not even make sense, because I mean, when I hold the bulb, right, I mean, I'm obviously going to feel the warmth, and I can calculate the energy that's been transferred to my hand, right? I can calculate that. So that would sort of be the total energy that the bulb carries, okay? That's the total energy. But you see, the thing is, with light, I cannot hold light with my hands to say this is the total amount of energy that the light has, right? I cannot do that. Hence, we don't really speak about the total amount of energy that the light has. But with light, we normally speak about the radiative energy, right? Because light, after all, it's always traveling through space at the speed of light, right? And so because of that, we can't hold it. Like, we can hold a potato, or we can hold a bulb, right? Or a rock or something. So because of that, we normally speak about radiative energy, right? Radiative energy. So you would also have noticed, if you've bought like bulbs sometimes, you would also have noticed that they come with a measure, like 100 watts, not watts, but watts, right? Watts. It obviously comes with, those 100 watts. It can be 60 watts. It can be 40 watts. So you see, that's what we call power. Okay, it's what we call power. Whenever you see the unit of watts, it's what we call power. Okay, 100 watts is power. Okay, so power is not the same thing as what? As energy, although they are highly related. Okay, although they are highly related, you've got more power, you've got more energy, but power is not energy. Neither is energy power. Okay, so how do we define power? We say power is the rate, and whenever you hear the term rate, know that it involves time. Okay, so how do we define power? We say it's the rate of energy flow. Okay, it's the rate of energy flow, and we measure, so the unit with which we measure power is watts. Okay, is watts. And 1 watt, I mean, the unit with which we measure power is watts, but the unit with which we measure energy is your joules, right? You've ever heard of joules, or your calories? These are the units that we use to measure energy. But when we come to power, and obviously it can be conversion and stuff, but when we come to power, we normally use the units watts. Okay, and 1 watt is 1 joule per second. right? 1 watt is 1 joule per second. That's when we now want to really get the idea of what's happening between energy and power. We measure energy in joules, right? Power in watts. But 1 watt equals 1 joule per second, right? For example, when you buy let's say a 60 watt light bulb at a shop, right? When you buy a 60 watt light bulb at a shop, remember I said a watt, 1 watt, right? Obviously you would buy 100 watts, but when you buy 1 watt equals 1 joules per second, right? So joules is what? Joules is the unit with which we measure energy. It's pretty much like when we're speaking about your speed, right? If we are speaking about how fast you are, what is the unit with which we measure speed? That's your kilometers per hour, right? It's your kilometers per hour, right? It's your meters per second, okay? So you see the relationship. But when we're speaking of a power, that's what? That's joules per second. It's energy per time, right? Energy per time. What is the amount of energy that's used per certain time? That's what we are really looking at, okay? So when you buy a 60 watt light bulb, what that means is it actually means, okay, this bulb requires 60 joules of energy for each second it is turned on. Okay, so that's pretty much what it is, right? So that's pretty much what it is. And so obviously when we speak about light, everyday experience tells us, I mean, I'm able to say a fridge is white because of light, right? So that's already telling me that, well, light has got something to do with color. Okay, it's got absolutely everything to do with color, right? I mean, we've spoken about this in our previous show, so if you're interested in that, you might just want to check it out. So light is actually color, right? So the absence of light, I mean, well, black is what you see or what you perceive when there's no light, okay, by definition. So black is what you see when there's no light, right? And hence no color, because by definition, light is color, okay? That's pretty much what it is. And so we're going to end on this. How does light and matter interact? Because it's from these things that we are able to discern, right? We are able to say this is this, this is that. Now, how does light and matter interact? So there are 4 ways in which light and matter interact, right? And in physical sciences, when we're speaking about matter is not like a problem, right? But matter in the scientific world, when we speak about matter is anything that has mass and occupies some space. So literally anything, as long as it's there, as long as it exists by virtue of existing, we call it matter. You are matter, and so you matter. Wow. Right? So that's what matter is. So the 4 ways in which light interacts with matter, okay? So this is so interesting. It's amazing. So obviously light can interact with matter in such a way that matter can absorb light, right? It can absorb light. So obviously when you place your hand near a bulb, right? What's going to happen? Obviously your hand is going to absorb some of the light, right? And hence your hand is going to start to warm up because your hand absorbs this light. Okay, it absorbs this light. So that we call that interaction absorption, right? It absorbs the light, it's absorption. And actually this is how some of the glasses works, right? I mean, your sunglasses, they actually absorbing some of the wavelengths of light from reaching your eyes, right? And hence you see a different color when you're wearing eyeglasses. Sunglasses, because some of the wavelengths of light are actually absorbed by the lenses from reaching your eyes, right? Wavelength, means a certain color of light, right? Obviously the light from the sun is white, and when it gets to your sunglasses, it's a white light, right? So it contains all the colors, right? All the colors of the rainbow, they are in a white light. So when it gets to your sunglasses will start to absorb some of the wavelengths of light, and it would leave some to pass through, right? And those that have passed through is what you're going to be able to see, right? Which is the color that you see, right? So it's absorption. The other one is reflection, or reflecting, or scattering. Okay, so what do we mean by that? I mean, you know what a reflection is, right? A reflection, that it happens when light sort of bounce off, right? It's light sort of bounce off on matter. It bounces off on matter. I mean, you know what happens on a mirror, right? You take a mirror, you point it towards the sun. So the light, when it gets to the mirror, it immediately bounces off. And in physics, complex mathematics, we can actually measure the angles with which the light bounces off and all that kind of stuff, right? The incident rays and stuff, we can measure that. But another way with which light interacts with with matter is through reflection or scattering, right? And can I tell you a secret? That's what happens in our atmosphere. Why is our atmosphere blue? That's because when light from the sun gets in our atmosphere, it is, and you see, I mean, these are particles. It's got a dual nature. These are particles called photons, and I mean, when light, interacts with our atmosphere is made up with a whole bunch of particles. Your oxygen, all of them are in the atmosphere, right? And when they interact with matter, if there's this light, right, it is scattered out. And it just happens that blue wavelengths of light are sort of scattered out more than all the other colors of light, okay? Which is the same reasons on why when the sun set, the sky would sort of appear to be a bit reddish or orangish, right? Whatever that means. So how does light interact with matter again? We spoke about absorption, and the second one is reflection, right? Or light can actually be transmitted, right? Transmission, right? Obviously at Lars, right, or air, it does not absorb, it does not, well, there's absorption, of course, some with that, but let's just say at Lars, transmit light, okay? A window that's at Lars, it transmits light. And what does that mean? It means light is able to sort of pass through, right, the other side of the glass to the other side, right? So that's what we call transmission, okay? And the last one is emission, right? How does light interact with matter? It's absorption, it's reflection or scattering, and then it's transmission, and then the last one would obviously be emission. And emission, I mean, obviously a light bulb emits light, right? That's matter, but it emits light, right? So that's emission. That's what we call emission. And then you would have sort of objects that transparent objects, they transmit light, right? But opaque objects absorb light, right? Opaque objects absorb light. So opaque is more like an opposite of transparent, right? But obviously materials, all materials are neither perfectly transparent or perfectly opaque, right? So as I've said before, your dark sunglasses, it's not perfectly opaque, but it's partially opaque, right? It's partially opaque and it's partially transparent, hence it transmits less light, okay? Right, so that's pretty much what happens, and obviously even the colors, we can then now start to speak about the colors and how they interact with light. Obviously a pink dress scatters out more red color and absorbs all the colors. Right. So the time has arrived for our common misconceptions today. Right. So excited. We're gonna be speaking now. It's time for common misconceptions. And now the question is, can you see an X-ray? Try to answer that. Can you see an X-ray? Well, the answer is no. You cannot see an X-ray. Hey, you cannot see an X-ray. So X-ray is actually a form of light. Hey, it's actually a form of light that it's got the wavelength of X-rays. It's actually very far too short. Right? It's very short for our eyes to see. X-ray is a form of light. Okay, if you've seen the video that we posted on Active FM pages, we were speaking about radio waves. Radio waves, that's light. Okay, you cannot hear radio waves. Right, you can't hear radio waves. It's light. Right. So can you see an X-ray? No. An X-ray is what? It's light, but it's with a wavelength that's very short for our eyes to see. So the question is, what actually happens when we saying, I mean, what's actually the case when we're speaking about X-ray things? Now, the thing is, when the medical X-rays that we get, obviously, from your medical physicists, these are images, okay? These are images that are made by special machines, and these machines emit this X-ray light, okay? It emits the X-ray light, and obviously the X-ray light would pass through your body, and then the medical physicist place some sort of a detector, right? They place some sort of a detector on the other side of your body. Now remember, we said now this light is having, so it's having, so the thing is, your body, okay, let me say this. This light is having a short wavelength, right? So we can't see this light. It's not like this light that we can see, the white light, right? That's called visible light. This X-ray is actually having a very short wavelength that we cannot see. Now what happens, the medical X-ray images are created in this way. These medical physicists have some sort of a machine that would emit the X-ray light, okay? And the X-ray light would pass through your body. It's able to pass through your body, right? It's able to pass through your body. Now, behind that, they place some sort of a detector, right? And when that X-ray, so the detector would obviously record what passes through you, right? It records what passes through you. So the thing is, you never actually see X-rays themselves, but what you see is the image that's recorded by the detector. Okay? That's recorded by the detector. Right? So you can't actually see X-rays. And by the way, if we are going to assume that you are, I don't know, you have some sort of an X-ray vision, that was going to be pretty useless. Okay, that was going to be pretty useless because, I mean, X-rays can sort of penetrate and that pretty much be nothing to see with your X-ray vision. Okay, that pretty much be nothing to see with your X-ray vision because people, walls, dogs, they emit no X-rays. Okay, so you wouldn't see anything with your X-ray vision if you wanted to have an X-ray vision. So that's pretty much what it is. And that's our common misconception for today. Yeah, so let's catch up again next week at the very same place, The Void Show.
Like what you're listening to? Follow us on Twitter at Active FM,
Instagram at ActiveFM777, and Facebook /ActiveFM.